what is a circumcenter? Well, first of all, the circumcenter of this triangle over here, ABC, is point O. You find this point by the perpendicular bisectors of each side. They all intersect at O over here. What is a perpendicular bisector? Well, it's a line that bisects the side that it's on from the midpoint over here, so that it is perpendicular to the side. A formula that a theorem that you can find that's interesting about perpendicular bisectors is this formula over here, the perpendicular bisector theorem. In this theorem, it states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the segment's endpoints. This is supposed to mean that this point, these two lines over here, AD and ABD are both equal. So that means that these two over here are also equal, and so on for each of the ones. If you just pick a random point from this line over here, this line CD, you'll be able to find that that point connected to A and B these segments will be equal. Isn't that interesting? Something else I would like to mention about the circumcenter of a triangle is that this point O over here, the distance between the three vertices and the point are all the same, thus making it the center of the circumscribed circle of triangle ABC. Next, let's move on to this formula over here. In this formula, R, which is over here if you didn't know, is equal to C divided by 2 sine C is equal to B divided by 2 sine B, which is equal to A divided by 2 sine A. Since all these are virtually the same except for the replacement of C and B and A, we're just going to focus on this part over here. So the first method of proving this is by looking at this triangle ABD. In this triangle, angle ABD is equal to 90 degrees, and that AD is equal to 2R. See, AD is the diameter of the circle. Since we know this, that makes it so that, wrong color. This makes it so that sine D, which is over here, is equal to C divided by 2R. Since angle D and C are both the same, since they're both inscribed angles and share the same arc AB, this means that sine C is equal to C divided by 2R. Putting this into this over here, you'll get just that. The next method, we'll be looking at this triangle A over here. in this triangle, sine angle AOB divided by 2, this angle over here, since this is an angle bisector, that's, well, perpendicular bisector, honestly, is equal to 2 divided by C divided by R. Now, something else about this triangle is that angle, well, not about this triangle, but specific angle AOB is equal to 2 times the angle C. Since C is an ascribed angle and AOB over here is an central angle. And they share the same arc too. Because of this, you can put C into this over here, making it so that sine angle C is equal to 2 divided by C divided by 2 divided by R, which, surprise, surprise, is equal to C divided by 2R. There you go. That's 2 ways to prove this formula involving circumcenters.